Welcome to SSI Meetup. Today we have our second webinar with Drummond Reed, and we had the first one also with Drummond, where he gave us a general overview behind the story of the SSI standards, which are DIDs, DKMS, DID, auth, and verifiable credentials. And today we will we'll do a deep dive into DIDs with Drummond. And in the next slide, I will share briefly what the ideas are behind what we're doing here. Basically, SSI Meetup is an initiative to empower global SSI communities. SSI communities means companies, people, organizations, whoever's interested in pushing SSI around the world, and want to do this in an open way, sharing with everyone, and to achieve sharing with everyone. All the content that we're publishing here is Creative Commons share alike license, which is we're using number 4, which is the latest one. You have the link here that you can check out about what that means. But in short, it basically means that we're making these PowerPoint presentations in the Google slide format available to you so that you can read them, download them, and use them, especially say, hey, I want to set up my own SSI meetup wherever you are in the world, or just share the knowledge. So we make it as open as possible. The only thing you have to do is to please credit back the creator of the presentation, which today is Drummond, and also SSI Meetup, and then you can just keep on moving and use this material to create your own local SSI communities. So Drummond, going from here, will be presenting the IDs. We have 18 people right now, and please join in. I'll be managing the chat, so if you have any questions, you can interrupt anytime. And please don't hesitate. And so last time we kept it small. This time, and in the future, what we're trying to do is to make this as dynamic as possible. So I will try to pick up your questions so that Drummond can answer them. And Drummond will cover what the ID means, where it's coming from, and how the structures work, where the standard has been developed, and why this is relevant to the whole self-sovereign identity system. So Drummond, coming from here, I think the next slides will be presenting yourself, so I don't have to interview you, and you can explain more.
All right, thank you very much, Alex. It's great to be here again and talking about a topic that I am extremely passionate about. And so again, for folks that didn't see the first webinar, I have been living the world of internet identity for the last 20 years. Been at all 26 instances of the Internet Identity Workshop, and a good 15 years in these various internet standards organizations. And I wear a whole bunch of different hats, and you can see them here. Primarily Chief Trust Officer at Evernym, and then a trustee of the Sovereign Foundation, where I chair the Trust Working Group. And all of Sovereign, what we're doing is building on these open standards, building a global public utility for self-sovereign identity. And you can see some of the standards. Ironically, what's not listed here is the most relevant thing today. I am the co-editor of the DID specification at the W3C Credentials Community Group, which I'll talk about here in the slide presentation. So let's dive right into it now. For folks that saw the first webinar, I'm going to repeat just a couple slides at the opening because I want to provide the overall context for understanding DIDs, because it really, they are, as I said in the outset, the foundational building block of decentralized identity. And so I want to quickly explain why. So here are the standard model for that we started with before. At the outset of the internet, this was how you had identity. You didn't have your own identity. You only had accounts at different organizations. But even just to do that with a separate username and password everywhere to have it be secure, we had to have standards for how we're going to do encrypted communications, verifiable communications on the internet. And that, of course, is a lock in your browser, SSL and TLS. But the hassle of trying to manage all those accounts as you started to develop all these relationships over the internet led to the need for a more efficient model, and that was what we call third-party or IDP federated identity. And there you solve the problem by putting a service provider in the middle. Now you have an account with that service provider, and they can federate your identity out to many different organizations, This, of course, and we know this on the web as social login using Google or Facebook or Twitter or LinkedIn. And that's very broad. This is used by many companies and organizations. And interestingly enough, it actually has developed 3 whole generations of standards to support federated identity over the last 15 to 20 years that this has been evolving. And so, despite all the advantages of being able to use this intermediate service provider and simplifying it for users, there's still a lot of challenges. It inserts an intermediary into your relationships. It limits what is available in terms of the information that can be shared to what's supported by that IDP. And the biggest challenge is no one federation, even Google or Facebook, covers everyone that you actually need to federate with. So we've evolved into, and the whole reason we're here at SSI Meetup is the self-sovereign identity model, and the third major wave. And that's distinguished because now we're back to a peer-to-peer model, but you, as an individual or an organization or even a connected thing, you have an identity, a full, you're a full peer with every other peer on the internet. You have your own independent self-sovereign identity. And that's instantiated. What makes it real, because it is, it's enabled by blockchain, but what makes it real is that you, I forgot to mention, when you have this relationship, you don't just have an account. With every peer that you share this identity with, you have a connection. And you'll see this come up over and over again. Self-sovereign identity is about the identity you have in the context of every connection you have, whether it's with another person or an organization or an app or a connected device. They're all connections. Now, what's at the end of those connections? It's a digital wallet. That's where your keys are stored. That's where your credentials are stored. That's where, over time, your tokens will be stored. And what makes that digital wallet work is some of the credentials in there you will issue yourself, but many of them that actually prove your identity are going to be coming from one of those peers. That's called the issuer of the credential. Many classic credentials we carry in our wallets today, they're going to come from the same folks, from the passport office, from the driver's license authority, from your employer, from your loyalty card, from your coffee company. And when you need then to go and prove your identity, you form a connection with another peer. We'll talk about that process here with WhyDIDs, and then you share a credential with them for them to verify. And they verify it by virtue of the signature on the credential. They'll verify the public key using a DID down on the ledger. So that is the first and most fundamental standard of what enables self-sovereign identity, is these decentralized identifiers and DID documents that are on the ledger. That's what the webinar is about today. Now, just to make sure the whole picture is clear, the second major standard is called DKMS for interoperable key management in those wallets, so that your wallet is not locked into one vendor and you can actually use different wallets on different devices and all have them interoperate. The third key standard is called DID auth. That's how you actually authenticate over a connection, a DID to DID connection. And then, of course, verifiable credentials for how you're going to interoperably have credentials that work across multiple wallets. So as we covered last week, these 4 emerging standards, I'll just put them up here. These are the different places that this work is going on or headed to. And the 2 that are most advanced in this are actually the top and the bottom. Verifiable credentials is a full working group at W3C. That means it's already in the stage of being prepared to become an official W3C standard, probably within the next year. Decentralized identifiers at the bottom here that we're going to be talking about today is actually in what's called a credentials community group at W3C. A community group is the stage before a working group. That's where you incubate a standard and you get it up to the point where you can make the case to the W3C and the members, hey, you should approve a full working group so that we can complete this as an official W3C standard. So I'll talk about that more at the very end. We're very close to that, to the end of that incubation process, and in the process now of preparing for the formal working group. So happy to answer questions about that standardization process, but first, let's dive in and get down to the nitty gritties. And this one is going to get more technical than the last one, because I'm going to repeat my introduction to the DIDs, but then we're going to dive down beyond that. Now, a quick way that I find to illustrate for people just how different DIDs are is to show what in the United States is the canonical identifier that we carry today here in the US. It's a social security number, and I'm putting this up on the screen, and no, that's not mine. The irony is that social security number is from the Wikipedia article on social security numbers. It's been used by over 40,000 people because it was printed on a little insert in a wallet that was sold back in the 1930s by a Woolwich company, and it was the social security number of the boss's secretary. And he just wanted to put something in there that would show what you could do with this little clear panel on the wallet. And so people would buy this wallet and it had this little half-size social security card in it, and they'd just say, oh, I'm just going to use that as my social security number. The point being, there's no way to prove in the United States that a social security number is yours. And the little cards they hand out are so trivial to copy that it's nearly impossible. Now, if you contrast that with what the IRS, the Internal Revenue Service in the US, has told us they want to switch to for filing of tax returns, it's something would look like that. That is a DID, a decentralized identifier. And yes, it's longer and it's not very human memorable, but you can prove that you own and control that. And that's because it is the address of a public key on a ledger. And you have the private key. So you can use DID auth, that we'll talk about again on another webinar in this series, to prove that you actually control it. And you can do that for as long as, as you're alive. This is your identifier. Now, you can just look at this slide and immediately recognize none of these numbers are human memorable. No one is going to, without an eidetic memory, is going to be able to keep this in mind. So what you're going to use to both generate and then control these DIDs is the same thing we use in most cases to control our address books today. I personally have probably over 1,000 contacts, and I only know the phone numbers for a handful of them these days. I use one of these devices, and I'm going to continue to for self-sovereign identity. Now, the other thing that is very different about DIDs is in the US, a social security number, by law, you can have only one. It's illegal to have more than one. But with DIDs, you will not have just one. You will, in fact, have thousands of them. And that's because, at least in the sovereign ecosystem, the default for individuals would be pairwise pseudonymous DIDs. Every time you form a relationship, you will share a different DID, and the other party will with you, and you'll have pairwise, we call them pairwise pseudonymous DIDs, and the keys behind them. So those keys are only used, those cryptographic key pairs only used with one other person or organization, which means every DID is not just an identifier, it gives you a lifetime encrypted private channel with that other party, that person or organization or thing that you've shared it with. All of us will have the capability to have private encrypted channels. And over those channels, we can now prove higher levels of trust using verifiable digital credentials. Another one of the key standards here that we'll touch on just at the end of this webinar. And then the best part about all this, there is no central registration authority. You register DIDs directly on either a public or private blockchain or distributed network, whatever, but there's no intermediary. This is why they're truly self-sovereign. You own and control them. So to summarize this, if you are an identifier wonk like me, what stands out is that a DID is four things, right? It's a permanent, also called persistent identifier that never needs to change. Okay, you assign it and it can last not just for your lifetime, but forever. It's a resolvable identifier, meaning you can actually go look it up on the target blockchain or system to get the metadata that we'll talk about, the DID document. And that's where you're going to find the associated public key. Thirdly, it's cryptographically verifiable that you own and control it, as I was just explaining, using that public-private key cryptography. And lastly, it's decentralized. You don't need any centralized registration authority. The reason there's so much excitement about DIDs and that this working group is now forming among the biggest of the W3C members is there's never been an identifier in history that does all four of those things. And
Drummond, just we've two questions here that are coming up. I don't know if it's the right time for them, but maybe you can comment. There's one question from Bashir. He's saying, could you please quickly explain how pairwise fits in the connection step? That's one question. And the other question is from Jordan. Are you saying that every DID will have its own private key that needs to be managed? These are the two questions that have been coming in so far.
So the second one is easy to answer, yes. Every DID does have its own private key that needs to be managed. So key management is really critical. That's why it was the second of the standards I talked about at the opening. Now, on the first one, I want to explain pairwise DIDs, but I think I should wait until a little bit later in the presentation. I want to go ahead and lay the groundwork, and then let's get back to that question. And because pairwise is an extremely important property of how DIDs can be deployed. But I think once we have a little bit more of the exposition out, it'll be easier to answer that, Alex.
Awesome.
Okay. All right. So, and Alex, I'm not seeing the question, so just let me know when whenever you have a question, just interrupt me. Okay.
Will do.
All right, sounds good. Okay, so let me get back here. So let's dive now down into some of the specifics of DIDs. And again, feel free to ask as technical a question as you want about any of what I'm going to cover here. So first, the overall format that we arrived at for DIDs was based on the pattern established by this RFC, which is 20 years old this year. It's URNs, Uniform Resource Names, are the standard for persistent identifiers on the internet, meaning identifiers that are assigned and never changed. And if you think about it, your phone number, your email address, or a domain name, none of those are persistent identifiers. You can if you stop using your phone number, it's going to get reassigned to someone else. Same thing with an email address or a domain name. If you stop registering it, someone else can register it. A persistent identifier is assigned once and never reassigned. So it always stands for whomever or whatever it was designed for. DIDs need to have that same property so you can always rely on it's never going to be reused for someone else. So we took this same three-part form, and that's what we adopted for DIDs. And the reason we did that is that second part, the method identifier, allows DIDs, what we call DID methods, to be designed to work with different blockchains so that you can have DIDs for Bitcoin and Ethereum and Sovereign and Verus1, and we'll cover the whole list in a minute. Now, each of those has what's called a DID method spec. And the first thing the method spec says is for that particular method, in this case, it's Sovereign, and you're looking at 22 characters here, it says here is how the DID will be generated. And all the methods, the 6 of them I'm about to show you, do it differently today. As it happens, Sovereign is one that does it specifically. It's generated at the edge. In Sovereign, your DID is a base 56 encoding of the first half, the first 128 bits of an ED25519 verification key. So Sovereign uses elliptic curve crypto in the ED25519 family. And so when you generate a key pair, it takes the first 128 bits of your verification key, your public key, and encodes it, and that's the 22 characters that become your DID. Now, when you go to register that, if you choose to register on the sovereign public blockchain, it will also check and make sure that that is unique. But in the generation process, that's as long as a UUID, and so they should, the chances of collision are very small. Now, that is how Sovereign does it. I want to now talk about DID method specs, and I can mention how some of the others do it. So a method specification says, okay, for a specific DID method, how do you read and write that DID on that blockchain or distributed network? Because they're all different. And these are the 6 DIDs that are DID methods that are actively in development today. Now we've already additional ones are being registered with the W3C credentials community group. So if you're working on a DID method and it's not listed here, just let us know or ping me, and we'll be updating this list, the authoritative registry for these different methods. And it's not there is no centralized place, but the W3C credentials community group is keeping track as different open source projects or organizations are saying, yes, we're developing a DID method. Now, quickly, the Bitcoin, Uport, and Blockstack methods, I can speak for all of them. They actually generate the DIDs by virtue of the address on the various ledgers. So in order to know what the DID that is there, you actually have to do the cryptographic operation of registering on the ledger, and then the address that you register will actually then turn into your DID. And I know with IPFS, it's actually, of course, content hash. And Verus1, I actually don't know the answer to that right now. I think it's also address based on the ledger. But in any case, these are the different specs. And so in each case, in addition to how you generate the DID, they cover the CRUD operations, how you're going to create, read, update, and you don't delete, but actually revoke a DID document. And that leads us into DID. What's in a method spec is how you're going to do these operations on a DID document. So that takes us into what's a DID document. So if you think of all of what DIDs enable, it's to allow all of the blockchain or decentralized network space to be considered a giant key value store, in which the key is the DID, and that's a location key, and the value you're going to get back when you look it up is the DID document. Now, this is a JSON LD document, JSON linked data, which is a standard JSON that has some additional rules for incorporating linked data so that it's globally understandable what's inside of it. And if you're not familiar with JSON LD, I highly recommend the JSON LD playground to go check it out. And the point is, it's a very simple document format, and what it's intended to convey to you is actually primarily the first 4 of the 6 things that I have listed here. And so the DID itself is always part of the DID document, so that if you find a DID document, if you've got it stored in a database or a file system or a program someplace, you can actually say, what DID is this? And you can quickly go verify that that is in fact still the current and accurate document for that DID.
Drummond, just one more question, maybe. There's Jason. He's asking, how will these DID method specs change the way people use Bitcoin, Ethereum, etc.? Don't they already have public keys, wallet addresses? Thanks.
That's a great question, and the answer is it won't change what you do currently with those ledgers in terms of what they're natively designed to do. What it does is it makes those ledgers capable of now supporting self-sovereign identity, meaning as long as you can use them now to start registering DIDs, those same ledgers are actually supporting the lookup of DID documents, which will make those public keys now available to use for other things in a standard way. Now, by contrast, there are new ledgers that are designed just to do this, meaning their only purpose is self-sovereign identity. The sovereign SOVRIN ledger is one of those. Veris1 VRES.ONE is another. That's all they do is DID documents and support for other self-sovereign identity primitives. So to existing ledgers, it just adds new functionality, and some of that functionality may eventually be used to actually enhance how those ledgers operate. I know that the Uport team is deep into looking at how DIDs can be used to help with management of Ethereum wallets and incorporated into smart contracts, so you can have smart ways of referencing the owner of the contract, different parties to a contract. So it just adds richness to what you can do today with Ethereum. So that's a short answer there. I can go into a longer one later. If any other questions, Alex, right now?
That's for the time being.
Okay, and we'll just keep doing this. Just let me know when one comes up. So again, after the DID itself, probably the most important thing you're doing with the DID document is that's how you're discovering the associated public key. Fundamentally, with DIDs and DID documents, DID infrastructure, we are decentralizing PKI, public key infrastructure, making it possible to discover and verify the public key for any DID on any blockchain anywhere. And in addition to the public key discovery, what you're also able to discover is how can I go authenticate right now in real time against that DID. And if I'm a website and someone is saying, here's my DID, right? It's like someone showing up saying, well, here's my username. Well, the only thing the website can do if there's an account is say, okay, well, give me your password and I'll check my own database. Well, with a DID, anyone can show up and go, here's my DID. The website doesn't have to keep any password or any internal database at all. Instead, it can just go, all right, I can look up your public key, sign this challenge, and I'll believe that that's actually you, that you control that DID, and that signing of that challenge and returning that is DID-auth. And again, you can now see DID-auth completely decentralized. There's no intermediary. There's no need for a federation server in the middle, and it will work every place. That's why we're excited about it. The third thing you need, or potentially, if you want to actually interact with that, the entity represented by that DID, it's called the DID subject, then how do you do that? And this is where the DID document can list service endpoints. And the services, the standard services that a DID document will point to depend again on who is using it for what. In Sovereign, we call that standard service an agent. You're going to interact with a sovereign identity agent, and everyone persons, organizations, connected things all have these identity agents. They are not on the ledger. They're off ledger, and therefore they don't, it's much more scalable architecture than having everything go through the ledger. At the DIF, Decentralized Identity Foundation, there's an architecture called hubs, and you have an identity hub. And it's a more database centric way of looking at how you would interact. But any type of service endpoint can be listed in the DID document, any type of service you want to associate with the DID. It's totally extensible. Timestamps and signatures are just there for integrity. Now, I wanted to quickly, for the more technical folks on the call, show you quickly here in 2 slides. So just what does this look like? Well, this is about as simple and straightforward as you can get in JSON. This is a DID document that actually, so here's the context is a standard JSON LD piece. The ID here, this element is the DID that this document describes. There's exactly one public key. It happens to be an RSA key, a signing key here. There's one authentication method, and there's one service, very generic service type in here. On the next slide, we just show, and you could have all of these, by the way, created, updated, and signature are optional. I'll point out for the more technical folks on this, you don't actually have to store this JSON document on the associated ledger. Obviously, that'd be difficult on something like Bitcoin. You can store a pointer to the document on the ledger. You can dynamically produce the document from attributes stored on the ledger. There are many different ways to do it, and all the different methods use different ways to do it. So, so that's a brief tour of DID documents. It's important for developers listening to this. A DID is a URI, technically a URL, meaning it is a standard identifier that follows the RFC 3986, meaning it also can support a path, a query, or a fragment, any combination. And there are very specific rules. If you have a path, then you are basically using the DID to route access to some resource that's not in the DID document. If there's no path, then a query or fragment is addressing things in the DID document itself. So all this is is covered in the DID spec, and that's sort of the guts of DID. So I'll stop right there and see if there are any other questions about the guts of DIDs and DID docs before I go into how we use them.
There are no other questions at this moment.
All right, excellent. And in this next section, I will get into back to that question about pairwise DIDs. So I just want to clarify now that we've sort of talked about the guts of DIDs and DID documents and DID methods. This is only, everything we're talking about is the very bottom of what I call the decentralized identity stack. And let's take a look at this stack so that can be clear. So we've got this DID layer, and again, I'm not calling out specific any one ledger or DID method. All of them together form the DID layer. Now, above that, in the full, in the complete picture, and this is the picture we use for DKMS, the Decentralized Key Management System design and architecture that been part of the team that's been developing over the last 18 months. We show two layers of agents, agents being a generic term for the piece of software that you're going to interact with to assert an identity or to exchange verifiable credentials. And we show both of those paired with wallets. Now, I want to clarify, different architectures and different instantiations use subsets of this. Some only use cloud agents, some only use edge agents, some use combinations in between. And we also, so you will definitely have peer-to-peer connectivity at the cloud agent layer. That's what it's for. This is like two email servers talking to each other because they're both available 24/7 in the cloud. We show a dotted line here between edge agents that would actually be able to communicate at the edge. There are very good use cases for that, but it's not necessarily something that every edge agent will support. If you look at this overall stack, and you can actually see it's very much like if you said browser, web server, browser, or email client, email server, email client. You'll see that, it's the same basic configuration. Now, where the DIDs come in this whole thing is whenever, let's just take an example of one edge agent wants to form a connection with these two. Let's say these are just two people, and one agent wants to form a connection with the other one. Well, in order to do that, you need to discover, if you have some pointer to the DID document, whether it's the DID itself or something that recognizes it, now this edge agent can ask either do it directly or ask its cloud agent, look that up on the ledger, find out the public key and the service endpoint, and now this agent can compose and send an encrypted message to the cloud agent, which has the endpoint, which can then, of course, if it's there, push it to the edge agent, and you've got a way to introduce and do an introduction protocol. That message is encrypted all the way to the edge, and this agent can turn around, and it's got a from DID. It can turn around, look up the DID document, get the public key, and then send an encrypted message back. And if the two parties have agreed, they can actually form a connection. Now, to initiate that whole process, you either need a public DID that's easily discoverable, or you need some form of an introduction service that will get this started without the public DID. What you can do, as long as you've got a way to kickstart it, is when the connection forms, this agent can generate a DID just for this relationship, just for this one connection here. and that will be pairwise pseudonymous. When this second party, if they decide, yes, I want that relationship, they can do the same thing and generate their pairwise DID and return it to the other agent. And now you've got pairwise pseudonymous DIDs, each of which has pairwise pseudonymous keys, a key pair that's just used for that relationship. And lastly, if you want to fully keep it pseudonymous, these two endpoints are also pairwise pseudonymous, meaning it won't look like the same cloud agent endpoint to anyone else in the world.
Drummond,
yeah, go ahead.
Just here, we have a follow-up question from Bashir on this. And he's saying, can an edge agent make a RESTful call to cloud agent? Then he says, example, website A makes a RESTful call to server, which is a cloud agent. So
yes, you can absolutely implement a cloud agent as with a RESTful API. And in fact, that is being done. It's definitely one way to do that. You can also, so I would say that is the diff approach, and that's why they call these hubs. In the sovereign approach, there is a agent-to-agent protocol it's an agent-to-agent messaging protocol that works actually for all of these legs. So one is more messaging based, one is more data-based, but both can work, absolutely. Any other questions in the queue, Alex?
Yeah, I have one more from Atul. Well, she is saying thank you, so that worked perfect. And so Atul is asking, with 1,000 of DIDs potentially for millions of identities and billions of concurrent transactions on the blockchain, could you speak to the performance throughput on blockchain, etc.?
Yeah, definitely. So one of the most important aspects of, if you're going to be doing pairwise pseudonymous, then notice all of the communications, the agent-to-agent messaging that takes place up here does not touch the public chain. These are private pairwise relationships, and in sovereign they use what we call microledger architecture. So as you create a DID and then share it with the other party, you're doing so on a microledger that's just shared between these two parties. And microledgers, of course, are as scalable as any cloud service out there, because you're not putting all the transactions through the public ledger. All that's needed on the public ledger is some way, when you're kicking off this whole dance of introduction, to publicly reference the first point where you're going to be starting. But two individuals here, this DID layer for them could be a micro ledger that's not the public ledger. And now, if you're going to engage in a transaction or exchange tokens for which you need to prevent double spend, then that is going to interact with the ledger for reconciliation of those tokens. And if you're going to engage in smart contract interactions, that can also need to resolve up to a public ledger. But these micro ledgers are they're also called state channels. There are many different ways to take these things offline, get the same advantages of the peer-to-peer crypto without having to touch the public ledger. And I can only really speak to how Sovereign is using that for scalability. I know we're in discussions constantly with the Uport team about how Ethereum's going to be doing that, Verus1, how they're going to be doing it, etc.
Yeah, nice. We have another question from Stanley, which you answered kind of already, but just maybe you want to expand on that, which is, this microledger is kind of like with a micropayment in Bitcoin, and he's saying in brackets, Lightning Network.
Yeah, exactly. Very similar. Really what it is it's standardizing, because again, Sovereign's building entirely on open standards, standardizing how any two edge agents or cloud agents can form these connections and basically set up a micro ledger and then synchronize anything they want on it. Certainly did documents, but also as they exchange verify. In fact, I should press down and go, the whole point of this, the microledger channel, is any form of encrypted P2P interaction. And so now the DID auth is not actually, you don't have to do that. The keys are on the microledger. DID auth is just a message exchange between the two of them. Verifiable credentials are exchanged that way, but actually could be on the microledger. And that would take me to the next slide. Just to quickly, I want to make sure this last piece of the sort of architectural puzzle, all of what we've just covered basically sets up, again, that channel, that relationship, that connection for then the exchange of these verifiable credentials. And those credentials, I want to make sure it's clear how DIDs play in those, because when you got a credential from an issuer, let's say a driver's license, and the Department of Motor Vehicles, for whatever governmental jurisdiction issues that, before they start issuing that claim, they register a public DID, okay, on their choice of method, whatever blockchain, public blockchain they want to use. They register that DID, and then when the self-sovereign identity owner, which the W3C calls the holder, will become the holder of the credential. When they come to the issuer will create that driver's license credential, assign it with the private key for that DID, and give it to the holder to put in their wallet. When the wallet is going to present that to a verifier, the holders also establish a DID that they use with the verifier, and with that DID, whether it's on a public ledger or a micro ledger, that's what they countersign that claim with. So when the verifier gets that digital credential, they're able to basically refer to the whether public or micro ledger for the holder, check the public key and verify that signature, and then check the public key on the public DID for the issuer and verify that signature. And that's how we can have an interoperable infrastructure, decentralized completely. There's no centralized authority for the exchange of digital credentials. And that's really what, even though it's just this bottom layer, what makes that whole thing work is this decentralized PKI. So any other questions pending right now, Alex?
Other questions now.
All right. Then I'm going to wrap up here just by covering what we are doing for DID standardization. A little background that I covered on the last slide. So DIDs started, they were actually originally conceived in the term DID by the Verifiable Claims Task Force, which was the community group that existed at W3C before they created the working group. So subsequently, in early 2016, Evernym, the company I work for, applied to the U.S. Department of Homeland Security, was actually funding decentralized work in decentralized identity. And we proposed that they fund a project to turn this concept of DIDs into an open standard. And that project took pretty much all of 2016. And we worked with, we went to pretty much every identity conference, Rebooting Web of Trust, Christopher Allen and others have put together, the Internet Identity Workshop, European Identity Conference, what's now Identiverse, all of them. And we had probably at least a half dozen of the blockchain identity vendors and many open source folks involved in that. And finally, that spec, which we completed in November of that year, in June of the following year, once they had created the Verifiable Claims Working Group, we then contributed to the W3C Credentials Community Group to take forward there. And we are currently now completing, we're in the very last stages of what we call the second generation of the DID spec. It's very stable at the WCCG. This is an open group, even though it is hosted by the W3C, no membership fee is required. It's open to anyone. It does have, you must agree to the IPR rules, so that the work product is protected and open for everyone to use. And again, we are now, we have started in the CCG the work to formally begin a DID working group. That is what's necessary to create an official W3C standard. I think it's going to take Manny Sporny there, who's done this many times. It's about a 6-month process to actually get the working group approved at W3C. So it's likely going to be around the end of the year that that's done. And then probably, at least another year before you have a full standard. But just wanted to, give everyone a set. These are the links, and I'll leave this up on the screen as we answer other questions. Actually, I want to go forward. I do want to provide a thank you to U.S. Department of Homeland Security, S&T, for funding this research, not only on DIDs, but subsequently on DKMS, the key management work that we'll have hopefully another webinar about. And then I'll just leave these links up for anyone that needs them, both how you can look at the spec, the issues list, and both W3C and Sovereign have discussion forums, again, that anyone can join.
Yeah, Drummond, there are no other questions right now, but I mean, but I think it would be interesting just for everyone to understand, because I don't think everyone is familiar with why these things are hosted by W3C and what these different groups mean. Like if you take the verifiable claims task group or the credentials working group, and how these are structured and how you evolve there, and how you can get involved into these kind of things and how they get started.
Yeah, absolutely. So W3C is one of the major open standards organizations for the web. The way I always think of it is you got the IETF, Internet Engineering Task Force, is the original sort of decentralized, crowdsourced standards org that created the original standards for the internet itself. Then W3C evolved when the whole web layer came about, and that needed standardization. It's different because it is a membership organization, and large members have a lot of influence there. So it is all standards are political, and definitely that's part of what's involved. But W3C originally was only a paid membership organization. You had to be you had to have a company or a nonprofit to join. It has since opened up much more and said we need to have individual involvement. We need to be open to open source and helping. So they added an entire, I think it was about 7 or 8 years ago, they added what they call community groups. And community groups are hosted by the W3C on behalf of the public. Anyone can come in and create a community group. Anyone can join them. There's no membership fees. There is a standard IPR agreement that if you're going to do work together in a community group, that everyone agrees it's going to be an open public standard, and you're not going to go in and have submarine patents and try and get everyone to adopt an idea. It's got to be a royalty-free open standard. So what happened is what's now verifiable credentials, formerly verifiable claims, started as a community group there, the Verifiable Claims Task Force, and then after several years, actually, in late 2016, they finally said, "Hey, let's turn this into a formal working group." And a working group at W3C is restricted. You do have to be a member of the W3C to participate in a working group. The IPR requirements it's a higher bar because you got to be very careful about patents. But working groups can produce official W3C standards that are actually voted on by the membership when the working group is done. So verifiable claims working group was officially approved, I think it was January of last year, and is about 18 months into its work now. The DID work is in the credentials community group. That's not yet an official working group, but that's what we're working on happening now. So anyway, that's how W3C handles it. ITF is different. There's no membership. It's just all volunteer. And then OASIS is yet a third example where they have both individual and corporate membership there. It's generally lower cost and more self-organized.
Awesome, nice. So there are no other questions right now. So if you want, we can get to the last slide. And just thank you, Drummond, for taking time again and to explain the IDs. I hope we will get you in the future to do one session on DKMS, which is one of the key components, and also another one for trust frameworks to explain how trust frameworks are relevant to SSI. And for everyone, please check out ssimeetup.org. There you have the Telegram channel, which is where we share any new sessions we will be doing, but you also share them via Twitter, LinkedIn, and email. So please follow all those channels, and we will be sharing in the coming 2 days the recording and the slides in the Google slide format, so you can download them and reuse them around the world. And please reference Drummond and SSI Meetup while you use them for whatever you plan to do. And thank you very much, everyone, for having joined us today. Thank you, Drummond, also.
And thank you very much, Alex. I really enjoy these. I look forward to doing more in the future.
Awesome. Thank you very much.